Now in this example, I want to show you how to find out the magnetic field of a solenoid. A solenoid of length 1 meter with N equals to 10 turns carries a current of 10 amperes. What is the magnetic field created by this current at the point well inside the solenoid? If the number of turns is increased to 20, what effect would that have on the magnetic field strength? The formula we need to use for finding the magnetic field of the solenoid is B equals to mu naught times N times I divided by L. Mu naught is the constant, which is 4 pi times 10 to the power of negative 7. N shows number of turns, and L shows the length of the solenoid in terms of meter, and I is the electric current in terms of ampere. So in this example, mu naught is 4 pi times 10 to the power of negative 7, N is 10, I is 10 divided by length, which is 1 meter. So that's gonna be 4 times 3.14 times 10 times 10 times 10 to the power of negative 7 is gonna be 10 to the power of negative 5. 4 times 3.14 times 10 to the power of negative 5. That will be 1.256 times 10 to the power of negative 4 Tesla. That's the magnetic field strength. Now what happens in the second part of the question? It says what is going to happen if we increase the number of turns to 20. So N will be 20. So it means that B becomes double. So 1.256 times 10 to the power of negative 4 will be 2.512 times 10 to the power of negative 4 Tesla. So as we increase number of turns, or as we increase the electric current, B is gonna increase. If we reduce length of the solenoid, B is gonna increase as well. So it is directly proportional to number of turns and electric current, and inversely proportional to the length of the solenoid. So that's how we find out the relationship between magnetic field strength and number of turns and electric current, and also the length of the solenoid.